Hello everyone and welcome back to the channel Math Simplified by HM. In our last video, we have proved the basic proportionality theorem. In triangle ABC, if line is parallel to side BC and intersecting AB at D and AC at E, then AD upon DB is equal to AE upon EC. Today we are going to look at the converse scenario known as the converse of the basic theorem. Please grab a notebook, pause when needed, and let us dive in. Before that, please like, share our channel, share links to your friends and colleagues, and don't forget to subscribe the channel for upcoming new videos. Let us start by reading the official statement of the theorem. If a line divides any two sides of a triangle in the same ratio, then the line must be parallel to the third side. That means in triangle ABC, if line DE intersects side AB at point D and side AC at point E in such a way AD upon DB is equal to AE upon AC, then DE is parallel to BC. Let us translate our theorem into mathematical setup using our diagram. Let us translate our theorem into a mathematical setup using our diagram. We are given a triangle ABC and a line DE that meets AB at point D and side AC at point E. We are also given the condition that these sides are divided proportionally. So AD upon DB is equal to AE upon AC. And we have to prove that DE is parallel to BC. To prove this, we are going to use a fantastic mathematical logic tool called the indirect method. We are going to intentionally assume the opposite of what we want to prove. Here we want to prove that DE is parallel to BC, but we assume that DE is not parallel to BC. So as per our assumption, as DE is not parallel to BC, so there is at least one line which is passing through D and parallel to BC. So draw a line DF such that DF is parallel to BC. We have shown it as by dotted line. Now let us play along with our assumption. If DF is parallel to BC, according to basic proportionality theorem, AD upon DB is equal to AF upon FC. But we are given that AD upon DB is equal to AE upon EC. As left sides of these two equations are equal, their right sides must be equal. So we get F upon FC is equal to AE upon AC. Now see that F and E are lying on the side AC. So if we prove that F is equal to AE or FC is equal to AC, then we conclude that A and F coincides to each other. How to do this? Here comes the algebra magic. We have F upon FC is equal to AE upon EC. Adding 1 to both sides, we get F upon FC plus 1 is equal to AE upon AC plus 1. Equating denominator, we get AF plus FC upon FC is equal to AE plus EC upon EC. Now numerators are addition of line segments. So AF plus FC gives AC and AE plus EC also gives AC. So we get AC upon FC is equal to AC upon EC. Numerators are equal. Hence denominators must be equal. The result is that FC is equal to EC, which proves that points E and F coincides. Therefore, DE is same as the DF. Hence, the DE is parallel to BC proved. Thank you. Like and share this video to your friends, colleagues, and subscribe our channel for upcoming proofs and videos.